Welcome back to CodinGame Fall Challenge 2023. So we're in the midst of writing some A-star searching, which is always fun. So I'll just jump straight back into the A-star, I guess. I mean, I can have a quick look at what we had planned, but I don't think it's okay. There's that, obviously. Not interested in these other ones. I don't even know really what to do with that one. It's useful information. So this one's like, if you see the enemy go into emergency mode, that means you know the monster is there, but you don't know which monster is there. So what can we really do with that? We can't pin down the location of one monster, but we do know that one of the monsters is there, so that's additional information, so additional probability, higher probability of a monster being in that region. I'm not sure what to do with that information, but it's useful information. Okay, anyway, we'll go with the A-star stuff. So, rank 488. Fine, that's decent. We're going to completely overhaul what we do now. So this will tell us if our... Well... Wait, oh, what? Why is the screen not showing? What the heck? Sorry, something's gone wrong here. There it is. Was that just for that 1 second, or was it the last couple of minutes? Alright, anyway, it's showing now. So we've set turn limit to 16. We don't want to branch too far. Even that might be too high because... Don't know. Leave it at 16 for now. So the other thing is we probably want to store the cosines and sines, as someone pointed out, because it's like, if you're only working with one angle, then there's no point ever. So you want to pre-process that, don't you? So let's say, I mean, how many points are we going to take around the circle? I mean, we could go for a nice even 30. That's a bit big, though. We might want to subdivide it further. Like 10 or something. I mean, it would be nice if it's divisible into 360. So 10. 10 would be. Hello, EXN GAYS. I'm not sure how to pronounce that. Gonna be lurking while I play some COD. Give you a follow. Would be cool if you check me out as well. COD. Which COD game have you played? Are you playing? I think I played COD until Call of Duty World at War. I never proceeded any further from that. But it was a pretty good series, at least the first games. I don't know whether the new games are of interest to me. I need to grab my coffee. So, but yeah, thanks for the follow. Anyway, so let's see. We want. Let's just go with. $10. Because that subdivides 360 into 36 angles. I don't know. It seems alright. Should we create a sign? So we want so it's gonna be K, so K times angle delta maps to sine of K times angle delta for K in range so it's gonna be 360 divided by angle delta, I suppose. Cosines equals math dot cosine. Alright, should we go with that? Pre-processed angle calculations. Alright, so should just run that, make sure it can actually do that. Module math has no attribute sine. Oh. Module math. Is it just sin cos? That makes more sense. Because that is what you do. I haven't done trigonometry in a long time. It's like, you have computers for this now. Alright, okay, so we've got... Whenever we want to do sine or cosine, we can just pull it out of this dictionary. No point, computing sine, cosine every time. It may not make much difference, but I don't know. Okay, so what to do? So we need a get neighbor function. So we got the heuristic. Fine. Get neighbors of a given pos. So the idea is we go 600 units in any of these directions. So normally angle starts 0 is the pure horizontal, and you go go anti-clockwise round. So if for the first angle 10 degrees, our position will be 600 times sine 10 for the, no. So it'll be the position of the drone plus the delta will be 600 sine, the delta x will be 600 cosine at the angle, and the y delta will be sine, 600 sine the angle. And this continues even past 90, 180 and stuff. It all works out. So sines and cosines will be negative appropriately. So if you just add, it should all work out. So like after 180, then the sines will be negative. Is that right? No, sine 90 is 0. No, sine 90 is 1. Sine 0 is 0. But I believe it will all just work out. So for k in range, so it's going to be 360 divided by angle delta. So the neighbor will be pos. So it's going to be move dist times sines k times, so k starts at 0. Angle delta it's cosines, isn't it? For the x. Sines for the y. Argument of type float cannot be assigned to parameter x. So, yeah, we do need to cast this to an int. So we'll just round it down. It should be fine. I mean, we shouldn't really be rounding down. We should be rounding the absolute value down, and then, well, it's like technically we might be moving to a space which is just outside the 600 if we're rounding down, because if we're going negative, then the negative numbers will be rounded to a higher absolute value, so that might take... what do we do? What's the easiest way to handle this? Can we just... I don't know, it'll probably be fine. Like, even if we try to go to a further point, it's not exactly gonna... Then it might matter. Let me have a think. Also, this is the delta, it's not the neighbor. So this is the bit we add. So maybe... Okay, let's just split this up then. Delta x, or dx equals that. Is there a sine function to find whether something's plus or minus. I don't think I don't know of one. So what I would like to do is round it closest to 0, wouldn't I? Sorry, round it in the direction towards 0. So if it's greater, if it's positive, we simply just do int of this number. If it's negative, we do int of this plus 0.5. Is that right? Hang on. No. Just do this. Alright, we're rounding. dx equals int dx if dx is greater than 0, else greater or equal to 0. The dx could be else it's just minus int math.absolute value of dx. Oh, abs is just, okay, fine. Is that right now? So it's basically making it positive, rounding down, and then making it negative. Yeah, why not? Let's just do that. Similarly, dy equals... I'm trying to be precise here because you could actually have a neighbor which is like... We want to give the precise spot that we're going to. Because this matters for the calculations. Like, there may be dangerous spots which are, you know, one spot away from being safe. Okay, so dy is that. dy equals int derive, dy equals 0, else that. So the delta is going to be dx dy. So the neighbor will simply be pos plus that. If so, we simply check if it's in bounds and output it, right? If 0 is less than or equal to neighbor dot x is less than width, and 0 is less than or equal to neighbor dot y is less than width, yield neighbor. That's it. That gets neighbors. So we ignore the ones that go off the grid. Even though you could go a bit closer to the sides, I don't really particularly want to. Okay, so that's the get neighbors function. So right, so how do we do a star? We do current equals q dot get. So that's the current node. And it should be d current because it's we put the distance in. Now we're doing lazy deletion. Is there a Python priority queue which has change priority as a method? Because sometimes you have that, and that's actually really what we want. I don't like doing lazy deletion here. It's annoying. And it's wasted effort. Python priority queue change priority. What I would like... No, it seems like people have done custom stuff, but in native Python you don't. Oh, heap q does. Probably we want to use heap q. Heap q gives you more functionality. It's just priority queue as a wrapper around. Yeah, so if you just want put and get, you use priority queue. We want to be able to modify let's use heap q. It's been a while since I used heap q, but so this is kind of like the Alright, where are the methods? Pop and return the current smallest value and add the new item. Does heap... Hang on, what was the... Oh, this is heap dict. Supports this. What would I... Interesting. Should I try using heap dict? Is it actually efficient? I mean... It probably would be, except, I mean, okay, you have the added overhead of doing the hash functions, but it lets me update priorities. The thing is, maybe I'm being a bit... So in this case, we're not going to revisit nodes often, are we? Because because we're kind of going that it's a 10,000 by 10,000 grid, so it's not often that we're actually going to be hit a node that we hit before. So maybe we don't need to worry about this. It's not like we're really going to find a shorter path to a node often. So let's not worry about it. We'll just use the normal priority queue. It'll probably be more efficient. If you're expecting to often find shorter paths to a given node, then you should probably use heap dict. It gives you efficient updating. But I don't think we will. So in that case, we just use priority queue and just kind of use lazy deletion. All right. So in that case, we need to check if dist. So, okay, so we pull out D and the current. So this is the priority. Now we want to check if we actually already have a better dist than what we're seeing here. That means we already processed this before and there's no point doing this one. This is just a waste of time. So if dist current plus h current. So if our current knowledge of dist is strictly less than D, because we have to take out the H basically, so because a D is the combination of the two, the addition of the two. So if, then we skip this one. That means we already know a better distance to current, which would yield a better G score. So this is just something that was supposed to be deleted, and we don't need this line, but it means if we don't have it, then we're just going to process all the neighbors and we'll just add unnecessary stuff to the queue because we already processed better neighbors before. Better distances to said the same neighbors. Alright. So the other thing is if oh yeah, we need one more helper method. Is goal. I don't want to try and cram this into the A-star search. Let's do this. So basically it's if is goal full horizontal. Can't spell this. That means we are willing to accept any y value of, so basically say return pos.y is less than or equal to, we're allowing it to go a little bit above. You know what? We can never actually arrive on the goal. So we should probably just accept getting within scan range. Which is 800, except the... How close do you have to be to guarantee scanning the fish? Let's read the things again. So, the problem is, okay, we move. They move. And then we scan. So they get a chance to kind of move away. So, so if we're kind of assuming that we are gonna turn the light on when we get there, so that we have the big radius, 2000. Might as well be optimistic. Then we would have to get into range 2000 to scan them. However, they would swim away if they're startled. At speed. And it... At speed 400. So I would say you basically have to come within 1600. Because if you come within 1600 and he swims away 400, then he's still within 2000. So we can say fish max speed equals 400. We should probably use that variable where we used it before, which was here. So basically we want light radius big minus fish max speed. That's how close we need to be for this to count as a goal. So let's do that then. So that's fairly generous. We don't have to get really close to the fish. We're just trying to... And that's good, because we might find ways of getting around monsters in a way that will be able to scan it without having to go all the way around an obstacle. So yeah. The thing is, this is going to tell us that if we are near a fish... Hang on, let's have a think. What was... Yeah, the problem with this is that it's just going to tell us to stand still if we think we're in scanning range, but we might not actually be in scanning range because our knowledge of the fish's location is a guess. So we're just going to keep staying still, when what we should be doing is just keep going towards our predicted location for our fish, because that will update us with a better predicted location. So we should not do what we're doing here. Instead, we should actually just keep heading towards the fish's location. So I would say the goal, we hit the goal when we are within 600 units of the fish. Strictly less than 600. Because that means it's only one more move to get to them. So... hang on. I'm still not entirely sure. I reckon we should just... okay, there's actually a cleaner way to do this. I think we should just add a neighbor here. Just add the actual goal position itself. In addition to these points on the circle, we should add the position itself if it's within movement range. Okay, so after we've done all these, or before even, because this is the higher priority one, you can say so goal pause. So we're saying alright, there's two cases. Alright, let's handle them separately. So if is goal full horizontal. If we're trying to surface, alright, we add the surface itself as a neighbor if we are within 600. Okay, so if pause absolute value of pause.y minus goal pause.y is less than or equal to 600 at move dist, then we simply add one neighbor which takes us to exactly that line. Why? Because we don't really want to go too high. We'd rather just go the minimum we need to deliver our scans. That will be in a position to go further down. If we go as high as possible, which is what the heuristic is going to tell us to do, then So being here will give us a heuristic of exactly 0. Being a little bit above will give us a heuristic of a positive heuristic, but it will be kind of like small. So it will prefer the one where we're on the line. Yeah, that's kind of what we want. We want to be as close to the line as possible. So if that line is within reach, we just say yield pause. So it's going to be the same x value, but just go straight to the goal's y and stop on that point, not any further. Else, so if it's if we're going for a specific position, now we say if the dist, so pause dot dist2 of goal pause, so the distance is less than or equal to, didn't we have a method for this? Oh no, this was for entities. This is actually not a good, it should have been based on pauses, not entities. Oh, it doesn't matter. We'll just write it out explicitly. If pause, so the distance is less than or equal to move dist squared, so we're working with integers. Then yield the goal pause itself as a neighbor. All right. And then, so those two will be yielded first. So they'll get the priorities. And then we also yield all these neighbors along the circle. So that should work out, because if we ever get those yielded as neighbors, it will go into the priority queue with priority 0, because the h value is like 0, and and so they'll come out, they'll be expanded first. So yeah, that should just work out. All right, so I'm glad I did this get neighbors function here and not in the middle of this, because it will look horrible. All right, so is goal. If is goal full horizontal, return pos.y is less equal to. See, the problem is we don't really want to allow there might be some weird rounding errors which causes us to go above the horizontal but not exactly on it. We don't really want to allow that, but whatever. We'll say if we happen to be less than or equal to goal pos.y instead of precisely equal to, then we have successfully reached the goal. No, let's just go with equals for now. And if for some reason it doesn't work, then we can change it to less than or equal to. We shouldn't really need to, but yeah, so we want to go exactly on the line, no further. That's a reasonable target to aim for. All right. Else return pos equal goal pos. Okay. So we do have equality, don't we? Yeah. So with all that in mind, okay, so the first thing we do is check if it's redundant. Okay, we do that. Now we check if we've expanded a goal node. That's the finishing point. If is goal current. Then we just break out. We don't need to do anything else. Just break out of this while loop. That guarantees we've found the shortest route. A shortest route. Because of course there's many shortest routes if you're coming to the goal from different places. But as long as we're using the discrete number of turns as the distance, so as integers, then yeah, we should find a shortest route. Okay. Alright, otherwise, it's not a goal, and it is not redundant, so this is basically, we're expanding a proper node here, so we've got to look for neighbors. So for neighbor in get neighbors, okay. So there's multiple things we need to do here. We need to, let's make a note of them. Neighbor is already checking if it's inbounds, so we don't need to worry about that. We need to check if it's safe to go there. So we need check if line segment crosses monster range for any monster. And we need to then check if final destination reachable by monster in one turn. And if both of those things pass, so it's not dangerous, then we can just say let's do the final bit first, just so we've completed the while loop. So let's say this is a good neighbor. We can actually skip this neighbor if we've already found a shorter path to it. So we can say if neighbor, because it's just a position, in dist and dist neighbor is strictly less than what we've found, so it's going to be current, then it's going to be dist to current plus 1. Then can skip this one because we know we've already found a better path to this neighbor before. Okay, so right now we're saying this is the fastest path we found to this neighbor. We don't know if it's a safe neighbor, but we know it's the fastest. So we now have to check if it's safe. Do that, do that. So we then get to this point. Now we know this is safe and it's the fastest route to this neighbor that we found so far. So we say, we update dist neighbor equals current plus 1. It took us a number of steps to get to current and then one more to get here. We update came from. We need to keep track of where we came from to be able to retrace our path. And then we have to put this neighbor in the queue. So the priority is going to be dist neighbor plus h neighbor, the prediction of how long it would take to get to the goal from there, even if it is the goal. That's the priority, and then we have to put the neighbor itself. Also, we need to be able to order pauses arbitrarily. And we can. Okay, good. So right now, if I were to use this, our drones would just not worry about monsters and try to find the shortest path to fish. I'm tempted to just try that, but yeah, let's do that. So let's just try to replace our hunt fish. So okay, if we're near a monster, we avoid monsters. We'll keep that for now. We're going to be getting rid of that eventually. So instead, hunt fish, we want... Oh, head to surface, we can also use that as well. Hunt fish, we can say... So we pick the one that's closest as the crow flies, just the shortest distance. We can keep doing that for now. The thing is, if we're not worrying about monsters, then it's kind of obvious what the next move is. But let's just use the A star anyway, see if it works. So target fish is that. So next move equals. So we're gonna have to do. Well, we haven't finished retracing the path. So when we break out of this while loop, we then have to so the last thing current we'll be looking at is a goal node. So current could be used here. Okay, so we might exit out of this while loop. Well, no, we might exhaust this while loop and we never find a goal. Alright, so we need to do a check. If current, if not is goal current, then return none, none. We failed to find any path, so just do something else. Alright, so that means, so at this point current is a goal node and we found a path to it, so we need to retrace the path. So while came from current, okay, hang on, temp equals current. While came from temp is not equal to the start, then temp equals came from temp. So we just go backwards through the map until we get back to the next node after start. So temp will be sitting on that node. So then we just simply return temp, i.e. that's telling us where we want, the next place we want to go, and couple that with the distance, because that's useful as well. The distance, the number of steps it'll take to get to current, where we're trying to head. Those are two parameters we want. So right now this is just a path that ignores monsters, so let's try using it instead of this. It should just give us the same result, really. So, like, if we do this, we get 18 points. So if we now use a star search, next step equals self.get path so it's going to be from drone.pos .get pos to target fish .get pos so it should replicate what their built-in pathfinding is already doing, but now we have full control. So there's no unknowns anymore. We're kind of trusting their pathfinding, and it's probably fine, but what else did we need? And we want this to be false. It's false by default. Okay, so yeah. Just want the first parameter. We don't care about the distance. So we just want to move to the next step, not the fish's location. So that should always be within range. Alright, let's watch it crash. So we would hope exactly the same thing happens. Maybe it might be one-off, depending on how their built-in pathfinding works, or not even one-off, maybe slightly off, because they may not be using, I don't know, they may have some rounding or something, but I don't know, we'll see. So we should expect exactly 18 points Oh god. Game object does not get path? What did I call it? Path. Yeah, it should be called get path. Path is not clear enough. Int object has no attribute x. Distance from neighbor. So neighbor in get neighbors. Did I accidentally return a tuple of ints? We yielded a pause, yield goal pause, yield neighbor, neighbor equals pause plus. Seems like we always distance neighbor equals current plus 1. Oh, current is an int. Ah, okay. Yeah. They're trying to add 1 to a pause. Oops. That was a mistake. Also, I didn't implement the turn limit, but it should just find the path anyway. But it probably would be good to implement the turn limit. Let's see. So we say if... Alright, so when we're processing neighbors, we say if dist current is greater or equal to turn limit, then we don't add any new neighbors. So this won't be infinite. It will cap out at 16. You might want to set it lower as well. Interesting. We'll just go something like 4 for now. Alright, go for 8 because usually you get there within 8 steps. It's what is going on then? This always happens with A star such. You always get an infinite loop at first. I think I didn't... This is the important bit. This is the bit which is supposed to prevent infinite loops. No, not this bit. There's also this neighbor stuff, so... Well, that's the line that we're making sure we don't repeat neighbors. No. I made this mistake before for advent of code. This should be greater or less than or equal to. This is... So if I just had this, we're saying, okay, if we found a better path to this neighbor before, skip this one. If I add equals here, we're saying, if we found a better path, or if we found a path equal to this path, skip this one. That's an important difference, because otherwise we'll just end up adding the same paths over and over again if we're being too strict. So we're saying, if we found the same path to this, then why are we adding this again? So yeah, that needs to be there, otherwise you can actually get infinite loops. Okay, that might be the issue. No, it's not. I mean, yeah, that's important. Could it be that we're infinite looping here? Let's check if we actually get... start and current. Let's check that we actually get something here. That would be very nice, because that means the... Ah! That's good news. That means that the really bulky thing is not infinite looping. It's just this thing at the end. What? So, our destination is 2,500, and our starting point was here. Is that... So, let's make sure. So, who is there? Nobody's there. Why is our starting point 4,350? No. Our start is here. Sorry. So 2,500. So this is our start. Our destination 4,350. So we're going for 4,000. What? 4,350. Why are we... That's like... That spot there, there's like nothing there. Well, actually, to be fair, we don't know where the fish is. We're predicting it to be there. Okay, fair enough. Because we see... That actually makes sense. This squid is in this rectangle. Actually, both of these are in this rectangle. So we assume it's midway. That's actually pretty spot on. Okay, so... That's interesting. We get a goal, destination. For some reason, our came from is not... So start maps to none, that's correct. Came from, are we always updating it correctly? Came from neighbor equals current. So if we get a valid neighbor, that's strange. I'm gonna have to log the came from map. See what it looks like. So the start location came from nothing. Okay, correct. All right, we've got a... How do I scroll this? We might need to just log it better. Pause x equals 2000. Why? How did this happen? Oh no, sorry. That's the first line. This is where the dictionary starts. Okay. So the start came from nothing. This node came from this node. Correct. We moved 600 units that way. That's good. This node came from here as well. Okay, so we're adding a whole bunch of nodes around the circle. This is promising. So that's like 36 different nodes. All right. And then we're sort of expanding on each of them. I think what we're going to have to do here is log temp. I want to see what the heck is going on here. Do we somehow get to none? Like, it should throw an error if it can't find a came from. So for some reason it's got like none maps to none or something weird. So it's saying that's our... So we go backwards through the map. We go here, and here, then here, then here, then here, then... And then we get here. Wait, maybe I'm misunderstanding. Maybe we actually do... We don't actually infinite loop here. It's somewhere else entirely. Maybe this is not the issue. We do get something. What was the problem then? So when we call this, we say maybe it's just too slow. We've got too much work. But we're only doing this once per drone. No, that's not the answer. Right, so we got move. Next step equals self.getPath. Alright, just log next step. Maybe the first drone is fine. No, I don't think so. 237996. So we get a next step. And then we move drone to next step. What's the problem then? Oh, maybe the next drone. Maybe the next drone is stuck in the infinite loop, not this one. This one's fine. It looks like we succeed. Alright. So I guess we should log before. Alright, we've got get path, log, getting path, start, goal, pause. Okay, so that's what we're trying to do here. Fine. So we're saying from 6,500, that's where we are, to 8,750. So about there. That's pretty close. That's our guess for where it is, but it's pretty close. So we want a path to go there. So it looks like the queue is filling up with stuff, but for some reason we're not getting. To the goal. We make a really small turn limit, like 2. Just go with the 2. This should terminate. Okay. 3. So it terminates for 3. At what point does it not terminate? Maybe it's just too many nodes then. So for 4 it's too many. 3 increase the angle then. Just make it like 36 neighbors is quite a lot. Let's go for like 30. Okay, that actually terminated, fine. Go a bit higher. Right. Wait, it can't get there in 6 turns? That doesn't sound right. Okay, it looks like it just can't find a way to get there. Oh, 8 turns was fine. That doesn't sound right. Why would it be 8 turns? Okay, let's just watch what they're doing. Are we making absolute sure that we're actually outputting the goal once we're in range? I think one of the problems is that with these discrete angles are a bit weird, because if you're here and your fish is here, because of the angles, we're only going to be doing like because we don't have the smooth angle. I think what we should really be doing is taking the angle which is perfectly towards the fish and adding the deltas from there. And I don't see any purpose in going full 180 either. So we could go like right angles, but at most, but I wouldn't see any reason to go backwards. So if we're doing that, nevertheless, I don't see why this is not getting there. Let's have a look at the get neighbors. So if it's not goal full horizontal, pause. Dot this to goal pause. It's less than or equal to move dist square. Ugh. Yield goal pause. Seems about right. Hello, Seg Prakash. How many lines of code so far? 355. Are you doing this competition as well? Hello, Ku. Trying to implement this sort of like A-star search with... I'm at 1,800 lines in C++. Nice. Thanks for the bug report. Oh yeah. I would have forgotten about that. I guess you noticed it in the video. Was that a very uncommon bug? Did you just not notice that happening? Did it not come up often? Was it just a case of your drones like very rarely getting caught and this was one rare situation where they did? It seemed like that might have been the case. Are you doing any pathfinding? Yeah, that's what I'm trying to work on now, Seg Prakash, but it's well, it's timing out, but not for the reasons I'd expect. It seems like it's... the logic is correct, but... it seems like the way I'm doing it, the way I'm discretizing the moves, it seems it's not able to find a path to the goal in a reasonable amount of time, which is not... okay, well, that means something's wrong, because it should be able to, but... The bug was that a monster was trying to find the minimum non-emergency drone. And if all my drones were eaten, then it was a min of empty list. Oh, okay, yeah. Yeah, I think basically every time you do it, even use the keyword min, you always have to check for an empty list, because I've definitely run into that issue often. Alright, so... yeah, I think... okay, one problem, which may not be the problem I'm having, is... I'm just splitting the 360 degrees into amounts of 30 or whatever. Starting from the direct horizontal and going around like that. But it makes more sense to start from the angle, which is directly pointing towards the goal. And then add the deltas around there. Because otherwise you're sort of making weird little turns to get to the goal instead of admitting the straight angle towards it as one of the possible angles. Thankfully, both of my guys getting eaten at the same time is pretty rare. Yeah. Yeah, I was thinking that, I probably mentioned it in the stream, that it would be nice if there was some way of checking if you've thrown an error throughout any of the last, say, 100 battles or something, without having to check them one by one. But yeah, maybe someone can write a browser tool for actually doing that, but wish that loss by timeout error would have you in position 2 with a red board or something. Yeah, it seems like there's no real reason not to do that. Yeah, I mean, yeah, they might say that it's our responsibility to find out errors and stuff, but that's just good for everyone, you know, experts and beginners alike. I think that's, yeah, they should really do that. Do you suggest going after combos first or closest fishes? I've just been going for closest fishes. And so far, from what I've seen from some of the high-ranking players, they're more focused on just trying to get all the fish quickly. So go for type 2 fish first. If you're planning to get all the fish in one big sweep, then would it actually matter whether you go for type 2 or type 0s? If you're planning to cash them in early, then it makes sense to go for type 2s first, I suppose. But for example, if you're trying to do what Ku here is doing and trying to get them all, then I don't feel like it wouldn't really make a difference whether you go deep or early first. Although going deep means you will meet some shallow ones on the way, so yeah, I guess for that reason it probably makes sense to go for the deepest first. Type 2 gives huge points, so reporting them first ensure not losing. Yeah, if you're going for the strategy where you want to get all the type 2s and then report them, and then carry on collecting other fish, yeah, you could do that as well. Though it seems, I mean, it depends on the seed, but it seems for a lot of seeds, it's the amount of time it takes to collect the last few remaining fish is not that much, so it seems like it's worth just closing off all the remaining fish rather than heading to the surface and coming back down. Especially as monster issues become less of an issue in the shallower waters. I mean, okay, what is the the max they can ever be. So they can never go above 2,500, but then I suppose... Oh, okay. Well, all the bands are below 2,500, so... monsters could chase you all the way there, I suppose, but it depends how far they're willing to chase. They'll start off below 5,000. Yeah, so my pathfinding right now, it probably is bugged. I don't think this is just a case of it timing out. I think it's... I mean, I could be more generous and say, let's change the angle delta to be like, I don't know, 45. So we're literally just going compass directions. Then we'll have to go kind of a zigzag path to get to fish, which we can do. And that's kind of working out. We get a double scan there. It's fine, doesn't matter. And then we time out here. So it seems like for the fish that are further away, we time out. But I wouldn't really have expected that. Even with zigzags, I don't know, it seems like it would be okay. So what are we targeting? The last thing we were trying to find was 3609 6250. So 3609 6250. So we're guessing a fish is like there. Hang on, 6250 3609. Is that squid to the left of us? No, it's actually to the right of us, so you'd have thought we'd go for this rectangle here, and we would assume it to be somewhere there. Hello, Zanail. Timeout? Yeah, getting timeouts now with this A-star searching. It shouldn't really be timing out, like it should be that... It should be fine to take a number of steps, like 3 or 4, just to get to this... Well, no, how far is it? It's like... This one is... about just under 5,000 steps away, so it should take about 10 steps. And we're setting the limit as 8, so it shouldn't... Oh, but this makes sense. It is going to time out because it's trying all branches of 8 steps, but in fact, it should take 10 steps to get there. So I suppose that does actually make sense. We should actually increasing the limit will actually reduce the chances of timeout, which is counterintuitive, but I mean, I suppose that's... So it's not turn limit we're worried about, it's really branching limit. So basically, if we put too much stuff in the queue, that's when we should abandon the search, not based on number of, not based on distance. So if we change this to like 16, the branching limit will be crazy, but we should always, assuming we're not worried about monsters, there we go, we're not getting timeouts now. That was counterintuitive to me. I thought that setting a limit would actually prevent timeouts, but setting a limit increased timeouts because it means we just fail to find the goal and then we branch out completely. And we get 16 points, which is exactly what we got when we were using the engine's built-in pathfinding. So that's good. That means our pathfinding is on par with that. The worry though is that if we don't find a path, we're just gonna crash because we're gonna have to figure out a way to end the search gracefully. I mean, there's ways of doing that. It's just a question of setting a sensible threshold. Type 2 first. 6 times 4 equals 24 plus 8 for type combo, 32 points. 2 type combos, 40 points. Just type 2 first gives 32 points. Minimum just for 4 fishes. Yeah. It makes sense. I think my instinct always was to go for type 2. So in the early leagues, I was prioritizing candidates with the higher type value. And right now, I'm not actually doing that. So it might be good to switch to doing that. Right now, I've just been going for the closest fish. But that's because my monster avoiding code is still not good enough. That's why I'm still doing that. But I think with this A-star searching, we might be able to turn that around. And actually prioritize going for the deeper fish. So the worry though is that this... Okay, so I'm not even sure that we should have a turn limit at all. Like, either we get there, in which case the turn limit, it's only going to be like fewer than 20 turns to have got there, or we can't get there at all, in which case we have to find a way to recognize that and cut out early. And it's not because of turn limit, it's because of branch limit. So I don't know if queue size is like bigger than Alright, well, okay, now that we've got it working again, can we maybe decrease this angle? Go for like go to 20? Well, that doesn't divide into 90. Go for 15. Would that still be fine? No, time's out now. Wait, timed out really early. Okay, but that's just too many angles to try. Maybe 30, double that angle. Thing is, I think we'll have to switch to not doing the full 360, just kind of like focus on the forward 180 range and focus the main angle on the direct vector towards the fish. Like, it doesn't make sense to just pick points along the 360 arbitrarily. We should start from the heading that's directly towards the fish and go... I mean, you can do it in a way so that you're more granular if you're close to the direct angle, and you're less granular if you're going further out. So then, in the further out bits, you could go to like 45-degree jumps or whatever, and in the close angles, you could go 10 jumps. I mean, that makes more sense to me because you're sort of trying to gently perturb around a monster. We could worry about that later on. So if I go to 30, okay, we're fine. So, I mean, we need to get it into a state that is safe and it's never going to time out. So But I mean, it's A-star search. So if we're not worrying about the monsters, it shouldn't be timing out at all. Oh, you know what? It's probably because the turn limit is still too low. Let's just change it to infinite or 30 or whatever. Like we should just don't worry about turn limit for now. This A-star search should just get there no matter what the angles are. Because it will just add a linear number of multiples of number of angles in 360, won't it? So it's going to be like... hang on. Oh, man, I am hungry now. But I wanted this to be a really long session. But now I'm really hungry. I have some seafood defrosting on the... Let's see, is it defrosted yet? It's pretty close to defrosted. Yeah, now I'm just thinking about eating. I can keep going for a while. Try and get this A-star search safe. So, okay, so what I'm saying is I don't think turn limit is helping me at all. Can we just abandon turn limit? Just take it out altogether. So just say, I mean, it's 10,000 by 10,000, so what is the worst case number of turns it would take you to get somewhere? I worked this out before, didn't I? So it was like, if you were to go all the way down, that would be 10,000 divided by 600, which is like 16 steps. And then you go all the way right, that's another 16 steps. So let's say 32. So... so just set it to 32 then, if we're going to set a limit at all. I'm not even sure if we should be setting a limit at all, but we'll go with 32. I mean, if we think about where the monster... If we think there's like 6 monsters or something on the board, what is the most loopy the path could end up being? I think at the very least, you'll pretty much always have the path where you hug the edges, right? So that would mean like basically 32. Because that kind of loops around all the monsters, unless one is at the edge, but usually then there'll be a path between them. They're not really gonna cover the whole horizontal. So at the very... in the worst case, I think you would get there in 32 steps. So yeah, we could say turn limit is 32. Okay, let's just make sure this actually is fine. Okay. Now we could actually use get path also for heading to the surface. So do that here. So instead of doing this, we say we just say next step equals self.get path from drone.pos.getPos, which we're using now, to well, okay, goal. It's a bit of a weird one. Okay, fine. We'll give the goal pos to be where exactly do we need to get to? It's within 500 of the surface. So we want y equals 500. We need to be exactly precise, because if we go to 500 and we actually needed to be 499 or something, then we're just gonna sit around forever. If the drone is near the surface, y is less than or equals 500. Okay, so we go to the line 500. Exactly 500. There's no reason to go higher. Alright. So we go, let's say we go to pause drone dot get pause dot x, and the y value to be exactly 500. Should we just make this another variable? Report range equals 500. Well, range isn't quite the right. Let's just say report height. Okay, so yeah, just do that. So we should, again, just get the same result. Hopefully not using too much computational time. That should really come just... Not that it really matters, but I'll put it underneath path. Wow, that was a long method, that whole get path thing. Head to surface. Suppose we don't really want to use the light. I mean, you could use the light on the way if you're at full charge. Just to get a... just to see what's around you. Should I do that? Yeah, go on. Let's turn the light on if our charge is at full. So drone dot battery equals max battery. Get the first parameter of that. Now, if we don't find the path, we should mean, ideally, we shouldn't be sorting the fish by their Euclidean distance. We should be sorting them by number of turns to get there. That's kind of the point of this. So we would run A-star search against every fish on the board. So this needs to be efficient enough that we can do that, and you would think it would be. The only problem is when we get into this situation, weird situation where monsters close off the area and then we have to go around them, and I don't know, there's just too much breadth or something like that. Should probably be fine for now. What angle are we using again? 30? Yeah, go on then. Alright, so... So yeah, let's try that. So when they're heading to the surface, we should now be using the A-star search. And it should just be fine. Okay. And they should always be going directly up. Yeah, that's good. Alright, I like this now, because we're now completely in control of what we're doing. We're not relying on the built-in, move method. We're actually saying precisely which space we want to go to, so that's good. Because I never really looked at the code for the move. I assume it's just like drawing a straight line and taking a segment along that. So now if I implement this monster stuff, then basically when we're heading to the surface, or we're heading to a fish, we're always avoiding the monsters. So we never have to have an explicit method for avoid monsters. It's like we're kind of passively doing that as much as needed to avoid getting killed, and we can still carry on with our work, so we don't just drop everything and deal with this. That will be a massive improvement. It's just and as long as there's a reasonable path to all the places we're trying to go, this shouldn't time out in any of the A-star searches. I just don't know how often we're going to get a situation where the monsters create a really weird obstacle. And then if that happens, we can just go for a different fish. So, I mean, we just have to time out of our pathfinding appropriately. Count the number of turns we've done in the A-star. And just cut it off at some point. Like 1,000 or something, I don't know. If we're doing it for every fish, then... Alright, I could do the ultimate test here and just submit this code. We should ideally get exactly the same rank, or roughly thereabouts, which will indicate that our A-star search is fine and reliable and not timing out. So should we just do that then? And if it times out, maybe we'll find out why. Because it's not doing obstacle avoidance, so it should always take the straight line path to the fish. Yeah, we timed out. Let's have a look. This shouldn't be happening. We're gonna get a pretty bad rank, probably. It got stuck trying to find... Wait, what? So we're sitting at the surface itself. We're sitting at 0. Wait, why are we at 0? We should never be going to 0. We should be at 500, first of all. So my heuristic is saying the distance to the goal position divided by move distance. There should be nothing that tells it to go further. How is that happening? So my opponent is also going above 500, but there's no reason to go above 500. Oh no, that case was where I got caught by the monster. Okay, fine. So let's check. Are we actually... Yeah, we're going to exactly 500 and no further. That's good. Yep. Okay, fine. So there are situations where we would end up at 0. It's when we get emergency'd. Alright, so then we crash when we are here. And we are trying to get to this place here. So it's like below us. 8, 7, 4, 9. So it's like there. Turn limit is 32, but how does it not? So going directly down should pretty much get us there. So why? If it's using the heuristic correctly, then this shouldn't be happening. So if it's going towards a specific goal, so the heuristic should be using the Euclidean distance, math.square root of current dot dist squared to goal pos. So that's the distance to the goal divided by the amount we can move per turn as a float. So that's always going to be slightly less than... We'd take one more turn to get there, so it'll always be slightly less. So yeah, that's a good heuristic, I would think. And among the neighbors, we're always picking something which is going to be kind of like pretty close to being 600 units closer. If the goal is within 600, we output the goal itself as, well, as a neighbor. This should, yeah, it shouldn't time out. So for k in range 360 divided by angle delta. This should all be kind of efficient. We're just using the pre-processed cosines and sines. So if it's positive, we round down. If it's negative, we sort of round up. So that's the pause. We add that to our current position. That's the neighbor. If it's within the map, then we yield it. So yeah, we're adding a bunch of neighbors each time, but it should just be in a line. So we should just be adding. So what is it? 30 to 360 divided by 30s. Okay, so it's you basically add 12 neighbors each time, but one of those will be pretty good. So in 10 steps or so, you add 120 neighbors into the priority queue, but should just get there. This shouldn't fail. Damn it. This always happens with A-star. Are you checking collisions? No, I'm ignoring collisions for now. This pathfinding algorithm should be ignoring monsters for now. So I just want it to behave like what the move method was already doing. Just returning the shortest... the next step along the shortest path. So ideally it should... Yeah, ideally it should go in a straight line. The only problem is this angle thing is a bit weird, so I should be starting from the direct vector towards the fish, and then also possibly going 30 degrees left or 30 degrees right in a full circle. And we can worry about how far we go with that later. But it should... That's what I should be doing. I'm not doing that, and that could be the problem. Instead, I'm just starting from the direct horizontal and adding 30 degrees in a full circle. But you'd have thought, even if you're going in 30-degree movements, you still should be able to zigzag your way towards the goal pretty quickly. I mean, in this case, directly down is a valid multiple of 30 degrees, so... yeah, it shouldn't really time out. We need to figure out what's going on with this priority queue. It's gonna take a bit of investigating. Instead of continue here, should I just break? So basically I'm saying if I reached a node and I expanded it and it has more than the turn limit, then there's no point just pulling everything out of the queue one by one, because they're all going to be more than the turn limits. Let's just break out of that. So, I mean, that's not going to solve the timeout. Oh, it could, if for some reason it's just taking a long time to... Okay, yeah, that's not the issue. I think it's probably just an arithmetic error or something, so it's for some reason going... It's just not heading towards the... I mean, the 30-degree discretization is annoying as well, so that's something I should solve as well. But that's not the bug, I think. Do we get something here? Do we actually get? Are we just failing to find a path once we've reached the goal? For some reason, we can't backtrack and find the path to get there again. No. We're actually failing in the looking for the path in the first place. Okay, fine. So, I mean, the explanation then is we're putting too much stuff in the queue and we're not taking enough out, and we're not reaching the goal. I think I will switch to changing the vector to be the direct. I mean, if I decrease this angle delta, you would think if I go down to 10, just 10-degree angle jumps, you would think it would just get the straight line. There's no reason why it should time out even for this. Okay, I mean, you're adding 36 more neighbors every time, but that's not a problem, is it? And it times out so early. It's got to be something wrong then. This would indicate that the problem is with the heuristic, surely. So the heuristic... I mean, I should just log the heuristic and see if it actually makes sense. Okay, put this all down here. Logging, so we're going from start. Distance to the start is 0. We put in the queue, we put the distance to the start, which is 0, plus the h of the start. Alright, I want to see what the h value is. We've never actually tried this. Let's see what it's saying. How many moves does it predict will take us to get there? 5.6 sounds about right. So you would expect only about, I don't know, 6 jumps, and each one adds another 36 neighbors, but they don't get processed, only the closest ones do. So... let's start logging... the... So is this priority queue being implemented correctly? So we put this tuple in. So it's taking the smallest value of this, which is the distance to this node, plus the remaining heuristic. That's... seems fine. And we're doing that later on as well, are we? Distance to this neighbor, plus h of the neighbor. And then it's also prioritizing this, but this is just like... doesn't matter, because it's just arbitrary. What matters is the priority here. And when you get from the queue, let's, I don't know, log queue dot size, queue size. Is that, do that, or approximate size of the queue? I think there's going to be way too many logs here to see anything. Yeah, that's ridiculous. The queue should not be that big. It should be 6 jumps. Each one adds, say, 36 neighbors. So a few hundred maybe, but not in the tens of thousands. So when we get to the goal, when neighbor is a goal, we still put it on the queue. So we add distance of the goal plus the heuristic of the goal. Heuristic of the goal absolutely must be 0. It can't even be like a floating point above 0. It should absolutely be 0. Is that true? So if we're sitting on the goal, then the dist to... We can check. We can just log the heuristic of the goal was. But you would say... the distance squared... Should be. Alright, let's try. H of goal. Pause. Also stop logging the queue size. Zero point zero. I mean, that's correct. So all right, fine. Hang on. Well, I want to log the queue size again. How quickly was it increasing? It should increase by about 36 each time, right? It probably was. $29, $64, $99. Yep, that's about right. Just discarding a few because of the edges. See, even early on, it's getting that to be so big. It shouldn't be. Oh no, this is the first turn. This is the first turn in which it's crashing. So, oh no, that turn it didn't crash. All right, let's go through the algorithm again, because I think I might have missed like a kind of like a check somewhere. So you get from the queue if dist current plus h current is less than d. So why am I saying this? Because we're using lazy deletion in this queue. So we're saying if we're expanding this, but there is actually a better distance, could this be because we're comparing floats using less than or less than? So what we really want to do is less than d minus epsilon. So what we're actually doing is, because often these are going to be equal. It's like we are currently sitting on the best one. But it's comparing two floating point numbers, so it might often be continuing when actually it should have been... So what if I change this to minus 0.001, an epsilon? I'm saying it's distinctly less than D. Not really, really close. Yeah, I think that could be the problem. We're doing comparisons with floats. It's kind of problematic. But I mean, there's several places where we're doing stuff like that. So where else do we need to do something like that? So dist is an int. That's fine. Or should I be a bit... Should I go like 0.1? I don't know. No, it doesn't seem like that's actually the issue, even though we should actually be doing that. Alright. Well, we know this isn't happening, but just put that there. So we're saying if we've already found this neighbor at this distance, or better, then don't bother processing this neighbor because we've already processed it before. That's correct. Although it's not necessarily... No, that's fine. Alright, we really want to see what the currents are then. So log d current. I want to see where we're heading with this path. Maybe it's going in a really weird direction. You would expect it to go zigzaggy a little bit. So, okay, we're trying to get from 7,999,500 to 5,999,3,750. Why? Who's sitting on 7,999? Okay, yeah, we're sitting on 7,999. We're trying to get to 5,999,3,750. So we jump to... So that's the start. Then the next thing we process is this. What the heck? Oh no, that's fine. Yeah, the Y is increasing. Yeah, I thought that was 10,000 for a second. Okay. Alright, good. So the X is smaller and the Y is bigger. Good, we're closer. Then the X is smaller, the Y is bigger. We're closer. Then the X is smaller, the Y is bigger. The X is smaller, the Y is bigger. X is smaller, Y is bigger. X is smaller, Y is bigger. Alright, we're really close now. In fact, can't we just make the jump now? We are... So when we get here... Also, these D values are weird. I thought... No, that's correct. You expect the D values to increase because this is an optimistic prediction, but it's always an underestimate, so it gets worse as you start getting closer and closer. You start... Yeah, that's correct. Okay. So when we get here, we are at 6109. So how far are we from... We're 110 off in the X direction. Let's write this out. So we've got 110 squared plus... and we are 190 off in the Y direction. So we want square root of that. It's going to be under 600, isn't it? Yeah, it is. So the next jump should be straight to the goal. So what's happened here? Alright, and now suddenly we've jumped to this one. What? Like, why would that happen? Surely that's even if we didn't reach the goal from here. Surely... there were other angles that were... there were other angles that were still slightly closer. Yeah, this is all wrong. What the heck? So there's two problems here. One is we failed to get to the goal. Like, why is goal not the next one? The next one should actually be 599993750. Like, we're right there. So distance is less than or equal to move distance squared. So if we don't square root it, it's that. 48,000, and 600 squared is 360,000. So oh my god. Is this even coming through then? Log. Goal is a neighbor. Is this even appearing in the yeah, it is. So we get the goal come through here. So goal here, we get to goal, right? Distance of the goal will be the distance of that plus 1. Came from goal equals current. And then we put that in the queue. Let's log what we're putting in. Well, there's going to be too many logs here. Let's say if is goal neighbor. I want to see it. I want to see that we're actually putting the goal in there. So we are. 7.0. Oh. I think I see the problem. It's because of this angle thing. Ah. I think the problem is it's okay, it's making a zigzag path to the goal. But it's not expanding that because it's thinking, okay, maybe there's a different series of zigzags I could do to get closer. And that's kind of correct behavior because of this weird situation I've created with the zigzags. Yeah, the zigzagging is the problem. So it's never sure that that's the shortest path because it thinks it could do a different series of zigzags and end up closer. And it's trying all the different ways of zigzagging. Yeah, okay, I get it now. But even if I go straight to the goal, this would still come up, wouldn't it? So what is this? Is found a goal which takes 7 steps to get to. But it thinks it can do it in 6. Because the estimate was 6.36, and that's smaller than 7 because we have to round up because we have to take one more step to get there. So it's taking forever to actually select that 7. Oh, what is the how do we... You know what? I think our heuristic is... I think we should actually be saying 7 and not 6.36. So the better... So the closer our heuristic is to the true number of steps, the better. That's fact. And what we're doing is we're trying to be... We're making it float. We're saying, okay, we think it'll take 6.36 to get there. When actually, you can't have a float. It has to be a discrete number of steps. It has to be 7. So a heuristic which says 7 is actually better than 6.36. That is the optimality condition of a star. So what happens if I just say... Yeah, I'm starting to get it now. That's how it's supposed to be. So it's gonna be math.ceil of that. And then just take like int, because math.ceil actually gives a float. And here it would be, again, math.ceil that. Yes. My worry was that this is now going to give a whole bunch of things with the same H value, but that's actually fine. They all get to the goal. And the ones that branch out won't. They'll have a worse H values. Okay. I get it now. So... So heuristic is an integer function now. And we win that one. That's just me failing to remember my data analytics from university. H should be as high as possible without going over. So I was leaving a gap between H, a gap that will never get closed. And that means it keeps trying all these lower H values, and it's never going to get one which is close enough to 7 until it exhausts the entire queue. So making H a integer method is actually correct, more correct. Or it doesn't have to be integer, that doesn't matter. It just has to be as close as possible to the true. And I wasn't doing that. Okay. Let's take out some of these logs. Oh, we can keep that one. Should we submit this again then? So... So yeah, now I'm starting to remember. Now, if you use A* search for the sliding block puzzle, the sliding puzzle, which is one of the classic things we did when I was in university, you use H to be number of... No, that's not a good example because that's integer moves anyway. Alright, doesn't matter. Alright. Where's this extra login coming from? Here. Yeah, take that out. I think we'll just resubmit this and make sure it passes. So that was just a whole lot of time spent making A* work on the most basic primitive calculation. Okay. Putting in, where are we doing that? I don't want that either. Yeah, take that out. So now we can think about trying to weave around monsters. Alright, submit this now. Hopefully this should bring us back to 500. I mean, that's our goal. Before we go any further, we should get back to 500, because we should be having the exact same logic now as before, just using A* search. And if there's ever any timeouts, then we still have to solve that before we move on, because that means something's wrong, because it shouldn't time out when you have no obstacles. There should always be the straight line path. Except for the fact that we're zigzagging, so actually that could still be a problem. But I'm gonna have to stop zigzagging and just go straight. So let's see what's going on. No, we're still timing out. This could be because of the zigzagging. I wouldn't think so though, but I don't know. Heading to the surface should never time out because it's obvious how to get to the surface. You just go straight up. Oh? Ah, yeah, because we didn't find a path. But we should find a path. We're not expecting it to not find a path yet. Hang on, this is not what I was expecting it to be. This is saying while came from temp is not equal to start. For some reason we're not, if we're going back through our came from map, for some reason we are bypassing start. We're not finding a path which came from start, but we should always come from start, so that's weird. Unless we're sitting on start right now. Ah. Wait, why would that happen? It doesn't matter. If we're in a situation. So if what is the correct behavior if temp is start? That means we were sitting on the goal, but we were still trying to get to the goal. What? What does it look like? Where are we? We're just sitting on the, why are we... No, this is not me. Oh my god, are there no fish on the... Oh, there's like no fish on the board. There's one fish. So... No, there's two fish. They still exist, but they're like... Oh no, there's one there as well. This is an odd error though. Who is crashing here? So he's trying to get to the surface. So he's got a scan. And this guy is trying to find a new fish to search for. So let's go back to logging this. This is an odd situation. There's still fish on the board that we haven't scanned, so... No, are there? There aren't. So he's trying to go to his current location. What? Why would that happen? Okay. If that happens, the algorithm should still handle... The A-star should still handle that. So we say if current equals start. For some reason, we're sitting on the goal and we're trying to go to the goal. That's still... The A-star shouldn't care why you're asking to do that. It should just say, okay, then just... Just return start 0, I suppose. I mean, yeah, that's the correct answer. But the real question is, why were you asking to do that in the first place? So he's heading... Oh, it's in head to surface. Oh, it's because he's got nothing else to do, and we just said head to the surface. Okay, so that's a valid call. It's saying you're already sitting on the goal, but we're still telling it to head to the goal. Alright, so that should fix that. That's fine. So A-star shouldn't complain if you're doing that. Okay, that's good. Let's fix that. So... let's resubmit that. We fixed another bug. So we got to 987, but yeah, that bug probably crashed us, because every time we've got no more fish to pick up, we crash. That's a big problem. Because we're winning those matches. That means we're basically likely to have won, but then we crash. Okay. Submit that. Getting there. Okay, getting some wins. Okay, acceptable. As long as we don't see crashes. Yep, these are just acceptable losses. Oh, okay, we got a crash here. We've got a better rank, but it's still a crash. There should be no crashes. Huh? Oh, is it RNG? Damn. Damn these players that throw in RNG. Oh. I think it was just a memory timeout on that occasion, but oh, maybe it's because of... Shouldn't be happening though. So it was a timeout for that battle. But running it again was fine. It seems it doesn't like this queue having lots of stuff in it. We could go back to 15 degrees, I don't know. Just to avoid a few timeouts, but it doesn't seem to be happening often. But we don't want it to be happening at all. Just try that then. Alright, we'll just see what happens and try and avoid crashes. Alright, the next thing I want to do, once we kind of stabilize this and avoid any avoidable crashes, I want to switch to change the angle to be direct. That will finally make it replicate what it did before with the move. Okay. Looks to be behaving as expected. Alright. As long as we're not getting any crashes, I think we can move on to this angle thing. So I just got to do a bit of geometry here. Alright, let's just... Okay, we're pink. Let's just have a look. Does it all look good? Huh. Oh, float division by 0? That's not good. Divided by norm. Vector equals drone.getPos divided by closest.getPos. So, it's saying if I'm sitting on the monster, then avoid monsters is pointless. We should, but I mean that's a valid case. We could still win the match. Okay. That's a funny situation. The monster is sitting right on us, but we still have a turn? Oh yeah, of course, because you always still have... commands, even if you're in emergency mode. Alright, so here, let's say... Alright, that's a valid situation. So if norm is 0, we don't never want to divide by norm if it's 0. Then monster is sitting on us. We simply return this can only really ever happen if you're in emergency mode already. But we'd still want to avoid dividing by zeros, so do we say true or false? Do we say... I think we have to say false. There is no way for us to avoid monsters. That's what the contract of this method is. We return true if we successfully made a move to avoid the monster. False if it can't be done. Right, that's one thing. So that will fix the divide by 0. But it also, I think we should just not do anything if we're in emergency mode. That's just wasting compute. Okay, so we actually get some points there. Okay, so the other thing is if we're in emergency mode, so are we even storing that information? We should be. Yeah, stop doing work while we are in emergency mode. Alright, drone is emergency Boo. Now, all right, so when we populate the drones, we want to say this just cast it to a bull. No, okay. Emergency equals 1. Is that it is treated as a bull, isn't it? Let's check. 0, 1? Or is it actually a parameter of some sort? I've never done anything with this. Inputs, where is it? 1 if the, yeah, okay. So, we get emergency stuff. And then we want to just say, if our drone is in emergency mode, then there's nothing you can do, so stop computing, pathfinding, and all that crap. Okay, same for enemies. And so we just say decide orders for drone. Okay, if drone dot is emergency, self dot wait. Just tell it to wait. It's the safest thing. Drone false. Don't bother turning the light on. Continue. Okay. So this shouldn't change anything because you can't do anything anyway when you're in emergency mode. So if this fixes that bug as well. We're fixing lots of bugs, that's good. Wait, what? We won? How did that change anything? Oh, I see why. Because the one thing... So, okay, all the commands do nothing. But the one thing we were doing here, which did matter, was that we were adding our target hunted fish to the list, which means the next drone will no longer target that fish because it's already covered by the first drone. So by stopping doing that, we're actually giving the second drone better work to do. And that actually gets us the win by 1 point. That's crazy. So that actually mattered. Yeah. Submit that. This could actually bump us up a few places. I mean, that turned a loss to a win right there. It's an odd situation, but I mean, if we go to on tough maps where there's lots of monsters, that could definitely come up. So I think in the last 20 minutes or so, we found several bugs that was not even in the A-star code, it was just in our code in general. It already existed, but it sort of was made clear. That's why I'm saying I really would like this to highlight errors, because you often just don't see them until you just kind of start looking inside them, and that's not fun to have to do. I would have liked to just, you know, be able to address an error. I mean, I can see this might be a problem if some people are getting errors every single match, in which case it might... Well, oh, I mean, you just show that they had an error every single match. I don't see any reason not to have this, unless there's... Can we maybe get a list of the last battles as a data file so that we can process it ourselves? That'd be very interesting. Alright. Just check that we're not still crashing and stuff. Let's have a look. Later on, I'm going to be playing some Doom multiplayer with some friends, which will be fun. Haven't played any sort of multiplayer shooter in a long time. Ooh, that was a draw. Oh, it's joint first. That's fine. Okay, it looks like we might be able to get back to 500. We should. Alright, so the next thing is, how do we do this neighbor method in a way that's more direct? So we want... And we don't want to go all the way backwards as well. That's kind of pointless. Well... We might... It should be fine. I mean, the A-star will just not prefer, or just prefer the ones which are more direct. So it should just work out. Okay, so we want so first we need to find a vector, unit vector, on a heading that's towards the destination. Okay, so in the pathfinding, it's the neighbor method we're changing here. So yeah, we keep this. If we put the goal as a output. All right, now we say Um, so the unit, ugh, can't remember any of this stuff. So it's like, okay, fine. Yeah, I mean, we just take the, it's gonna be well, it depends on whether you're going full horizontal and so on. Okay, so if is go full horizontal, then vector equals all right, let's just make sure. Okay, so if pos equals, let's say if is goal pos. We don't want to be divided by 0 again. So if for some reason we're trying to get neighbors from the goal, shouldn't really be doing that, but if we are, then break. No, return. So we only ever return a neighbor goal pos. We shouldn't even return that, to be honest. Do we? Yeah, a neighbor should be a movement. All right. So if we are sitting on the, if we are already on a goal, then there shouldn't be any valid neighbors anymore. There's no more step. There's no step we can make in the direction of the goal. All right. So just in case, because we otherwise we'll get divided by 0 when we're doing this vector stuff. All right. So if is goal full horizontal, then the vector is pretty straightforward. It's just pos 0 minus 1. Go straight up. Else vector equals, so it's going to be goal pos minus pos. Should I make a method to get a unit vector? That might be useful because we've done it once already, so. Define get unit vector so it's basically the norm equals so that's going to be do we really want yeah math dot square root of actually, to avoid rounding issues, let's say scaled vector. So that says we scale it to a certain number. That way we can only do the rounding at the end, so we don't get intermediate rounding issues. So the norm, so here we've got a float. So the norm is going to be math.square root self.x plus self.y Okay. Okay, so it's basically what we did before. We could copy some stuff. We want this logic, basically, don't we? So... dx, okay, so dx equals 6 scale times f.x divided by norm. So yeah, divide by the norm to bring it to a unit vector, multiply by a scale. And now we want to round down if it's positive, up if it's negative. Alright. So we got dy equals scale. Return pause dx dy. So scaled vector. We can actually use that here as well. We could say well, it's not quite the same thing here. It's fine. Okay, so so we get this dot get scaled vector move dist. So that is wait, no, what are we trying to do here? No. Actually, we want the unit vector because then we're going to rotate it by all the different angles and then scale them up and then round. The rounding should be the very last thing we do. We don't want to round it now and then rotate according to the cosines and sines and then round again. We're just going to accumulate rounding issues. So we don't want scale vector, we want unit vector. and we want it to be... okay, we don't... Just, we don't want any method here, because we're dealing with integers here. We just want floats, so we're gonna have to say, unit vector. Okay. Unit vector equals, and it's not a pos, it's a tuple. So it's going to be, so the norm equals square root. You can say we can make a get norm method at least. Can't do much more with this geometry right now. I need to finish soon. Norm equals, so it's going to be that dot get norm. So the unit vector will be okay, let's just start making variables here. We've got the vector. The norm is going to be v.get norm. So then the unit vector sake will be the tuple of vector 0 divided by norm, vector 1 divided by norm. It seems wasteful, like we should really just have a pos that can do floats, but kind of want to force the poses to always be ints so that it's valid for the map. I don't know. Right, so we've got the unit vector. Either way, we've got a unit vector. Right. Now, with that unit vector, we kind of want to try all rotations of it. So, for k in range 360 divided by angle delta, so it's going to be I've got to look this up. How to rotate vector by x degrees, or whatever, n degrees. Formula for rotating a vector in 2D. It's so the x value will be cosine the angle The interesting thing here is that you don't need these cosine and sine tables. You just you can do this repeatedly, just with the same cosine 30 over and over again, and just keep rotating it. That probably would... No, but that could induce rounding errors too, as you go along. So it's better to use the full angle, I think. Yeah. So if we want to rotate by n lots of beta, where beta is like 30 or whatever, it's going to be n times beta. Okay, so it's... Okay, so it's rotation equals, it's going to be k times angle delta. Is this for clockwise? Anti-clockwise, yeah, okay, fine. So the x value is going to be cosines of rot times the x value times unit vector 0 minus the sine I see. I'm starting to get it now. For the sines, it's going to be like rot times unit vector 1. So it's a transform, a change of, what's it called? Frame of reference. So we're doing the old thing as if the whole frame of reference is rotated. So this dx will be that, and then we can do the rounding thing. Dy will be sine. So it's going to be like sine. I haven't multiplied yet. Okay, so sine of that times x1. So it's... So in the first one it's x and y. And then the second one is x and y again. It's sines rot times x minus cos... It's not minus, it's plus this time. Plus cosines rot times the y. Now this whole thing is multiplied by move dist. And then we do the rounding at the end. We could make a method round towards 0, but we're only using it twice here. I guess that's fine. So we get the unit vector. So k, for k equals 0, rot will be 0. So cosine rot cosine 0 is 1. So dx will just be the old x multiplied by move dist, and the y will be, so that would be 0 cosine will be 1, so it'll be the y. So it works out for k equals 0. But that's the important thing. We get, as one of the neighbors will be the very direct root. And then that looks good. So that's just changing the neighbor function. And instead of taking a vector and rotating it, and then rotating it again, and rotating it again, which could accumulate error along the way, we're just taking the original unit vector and multiplying it by the full angle each time. Rotating by that full angle each time. So it shouldn't accumulate any errors at all. Unit vector's a float here, which we calculate once, yeah. Here it's an int, but I mean, should be fine. We're multiplying by a float. Okay. Oh man. Let's test that runs, and now we should hopefully zigzag a bit less. Maybe that will get us a better rank. I mean, it should mean we take a more direct route, unless the zigzag happened to be helping us avoid monsters without even trying to avoid monsters. Get norm shouldn't ask for anything. But... Oops. Okay. Pause object is not subscriptable. Vector. Oops, I should be using unit vector. Wait, what? I am vector equals. This one is a pause, of course. Use a pause as much as we can until the moment we step into the floating point world. Okay, this is quite nice. So we only enter kind of the floating point world for the purpose of this, but then we jump back into the pauses. I like that. That way we kind of keep using pauses for movements and stuff. What was the old score? I don't know. Alright, well now let's see if it looks like we're going more direct than before. So we're the pinks. Why did it do that movement? I guess he's going for the octopus. Because he assumes this squid might actually be more like here. And this octopus, I think he's assuming, is like here. That makes sense. Because we don't actually know where they are. So that seems like a very shallow part, though. It looks pretty good, though. Alright, so we're at 486 right now. Let's see what happens now. So this is basically just changing from using the built-in move to our A-star search, which should hopefully give us the same result. And now we're going more direct instead of kind of a very arbitrary, discrete angle. Let's check if there's any issues. So it should just be better right now, especially for the first fish that we're collecting. So the big change is going to be when we start weaving around the monsters, and that's where my worry is. Oh, it's just normal loss. They just won very quickly. All right, so let's see what happens there. Man, there's only 1 and a bit days left. Tomorrow it's just gonna be like, I don't know, I'm just gonna put in the full day from the moment I wake up till the end of the challenge. I don't know. Because I still have ideas that I want to get on. Okay, I mean, okay, just to make sure we put to do here so we don't lose track of these. Those are the two big ones. That's everything rests on that. That's what we're trying to work towards. Oh, we dropped a bit in the. That's still 13%. Okay, so. So we can say, here we can just switch to using. Now, okay, slight issue here. That's a float. That's an int. We shouldn't be doing that. But actually, if the norm is 0, we should probably just return an int. Just to make it clear that that's if self equals the origin. No. Yes. Return 0. Okay. Just. Yeah. Okay. Alright, that's a pretty chunky get neighbors method. One of my bigger ones. Alright, that I've done before. Alright, so that's good. Now I like the idea of. Wait, so what's my angle right now? 15. Okay, that's fine. I'm wondering if we should just instead of going from 0 in a full circle, we should just kind of go to kind of like minus 90 and plus 90. No, I think if there's a bunch of monsters here, I do kind of want to be able to go back and go around them. That definitely may well happen. Yeah, I think we'll just go for the full 360. Seems to be fine so far. I'm probably going to have to stop there. This is a nice, stable situation to be in before I mess things up by avoiding monsters. So we'll have to have a threshold cut out where we're kind of sure that we can do this much work safely without crashing. So that we'll have to keep an eye on the queue size. Just count how many times we put stuff into the queue and just set a threshold. You would expect... Well, not how many times we put stuff into the queue. How many times we pull stuff from the queue is really what I'm interested in. Because that we can expect, if we're going quite optimal, it will just be like the number of times it takes to get there. So like, if we pull stuff out more than 30 to 40 to 50 times, then we're starting to have issues. Like you would expect even if you're backtracking a bit, you would go like 1, 2, 3, 4, 5, 6, 7, 8, 9, you know. Reasonable numbers will be under 50 or so. So the moment I pull 50 things out of the queue, then we're in trouble. The rank is not that high, but then it is only 30%, so maybe we just have to wait. Let's just check. Are we getting any timeouts or anything? Nope. Big chunk of losses here, but it's fine. Should we just have a look at this one match, just see what it looks like. Right, I don't like this movement here. What is going on here? Why is he going in such a shallow angle? Where is his target? Does he think the fish is there? We'll have to check the... restart targets, I suppose. Something does seem a bit weird. Well, let's... Like, this all rests on my unit vector being correct, to be honest. If that's wrong, then a lot of other stuff is going to be a bit off. Let's check that again. Okay. If we move horizontal, then that's the unit vector 0, -1. Otherwise, we take goal pos minus pos. Take the norm. Then we create this tuple, which is vector.x over norm, vector.y over norm. And then that seems fine. K in range. So when K is 0, I mean, as long as we're getting the K equals 0, we should still be getting some good movements, right? Because we should always be using the K equals 0. So that's a good way. That's an easy way to check. Like there shouldn't be any. We shouldn't actually be using any of these other K values. Yeah, this rank doesn't look like what I was expecting. All right, let's log. This. I want to see what it looks like then. Okay, so at the start, those are our... So we've got 399,500 looking for 1999,3750. So that's like... 3750 is like there. And we're going about there. Seems fine. It's guessing that these fish are around here. That's in the middle of that rectangle. Seems good. Oh yeah, what, can we put these things on? There we go. So it's guessing they're around there. That's correct. And the other guy is assuming it's going for same height and 8999. So like there. Yeah, because he sees this rectangle, so the midpoint there is like there. Seems good. So they take one step. Wait, what? So he's going... No, okay, something's not right here. He's going there. One, yeah. He should definitely... No, he's not even going left. And he's going at a weird angle here as well. Let's have a look again. So rot 0 is the one we're interested in. That stuff. Okay, this is very easy to mess this up. So cos rot times unit vector 0 minus sine rot times unit vector 1. Sine rot times unit vector 0 plus cos rot. So it's plus minus cos minus sine, sine plus cos. If k equals 0, log... No. What am I trying to log here then? If I log the unit vector, that's going to be too many... We already think our H method is fine, so it's... Alright, we'll just have to have a look at what neighbors we're getting then. Log... Let's say if... I think there might be an issue here where if it realizes that going straight towards the goal would take the same number of steps as going kind of in a weird way, just because it happens to not really be that far, then it won't decide which one to pick. But then I don't think that's the issue, no. We should always prefer the one which is more direct, but I think this will all work out such that it will. I mean, Might need to fix this next time. So he's supposed to be going here. Oh. Maybe I'm just not associating the right moves with the same, Oh, hang on. Maybe it is actually fine, but I was looking at I was connecting the next move with the previous. Hang on, let's have a look. So it's this move is what we're interested in. Okay. Not what we see on the board, because that's, I don't know, that's... So 399, 500 is the... Okay, this is the first drone, right? I'm interested in the second drone, because he's a bit weirder. Right, he's going towards 1999, 3750. And it says... Go... to 4013... 1099. No, that can't be right. Oh, and its predicted H value is 1. Wait, what? Are we just thinking everything is distance 1? What the heck? Our H value is a Boolean now? What's happened? No. Start. Pause. Well, what's the 1? Oh no, that's the order, that's the light. Forget about that. Whoops. Okay. Let's log the H value then. Not that it will help much, but I don't know. So it thinks it will take 6 steps. Why is he, this guy is heading to the surface, right? Yeah, I think the problem now is that it's just, if it finds different routes that all, in theory, take the most number of steps because of this ceiling thing, then it just picks one which is a bit, which is not as efficient. But then it doesn't matter for going to the surface because this was the reason I did that heuristic, which was like a floating point, but that wasn't quite correct. So how do I deal with this? I reckon when we pull things out of the priority queue, we actually want to probably want another parameter here, because a lot of nodes have the same G distance. So of all of those ones, we probably want to pick the one which is minimum H distance to break ties. No, not H distance. That's already rounded up. Should we just break ties using a using the Euclidean distance then? So here we put, so the first parameter is the G distance as it must be, and then could just put the Euclidean distance to say so basically if there are several different nodes which are expected to take one turn to get to the goal, I'd rather just take the one which is physically closest first. And that's not going to harm anything because we're still keeping the G-score as the ultimate, the first parameter. So let's say start dot dist to well, it depends on whether it's horizontal or all right, define raw dist to the goal. Right, so so this uses this. So this gives us the non-int version. That's the floating point version. And H, the heuristic, we have to obey, give the best heuristic possible. So we have to say math.ceil raw dist current return int of that. Okay, but we want raw dist to break the ties. I think this is fine in A star. So here we can do, so we do the G distance, which is the we can't ever violate that, and then we've got the raw dist of start, and then start. So when we pull out of the queue, we get the raw dist, which we don't care about, and then the current. And when we put in here, we've got raw dist neighbor. So this is hopefully always prefers the best route, which we should do because we don't really know if the fish is there or not. So we want to be as close as possible. Starting to think there's probably an algorithm which is better suited for this, a modification of A star which is better suited for these cases where you're kind of approximating a floating point situation. but where there's so many grid cells that you actually want to pretend it's like... Alright, does this make more sense? No. There's still... Well, I don't know. Where's he going? He's going... Should be going to this point here, so he would go this angle. But it looks like he's going a bit shallower. That doesn't look right. I can't do this now. I've got to do this later. Alright, let's just, if k equals 0, I want to log some stuff here, see if we can actually get these. Log. Unit vector. And dx, dy. They should be the same. For k equals 0, there shouldn't be a difference between the two. So if there's difference, then there's actually a bug. Oh yeah, well, it would be multiplied by 600, but I mean, aside from that. So this one makes sense. I mean, go directly up. I'm gonna have to hand calculate these at some point and just work out if it's actually the correct. Maybe it's just because of the visualization, it looks a bit weird. I don't know. This one is clearly going 8999, so 9,000, 3750. So 3750 is halfway. 9,000 is here, so it should be going here. It does, and where does he end up going? Eight four five nine 885. 84. That doesn't even look like it's 600 away. Oh, it might be, yeah. Because our light radius is further. But that's too shallow. It's supposed to be... Yep, there's a bug, definitely. We'll have to figure this out next time. Alright, that's enough. 508. It's not that much worse than before, but these angles look horrible, so there's something wrong. They're like always slightly off. Like, I get that if we don't break ties, then it's just going to arbitrarily pick bad angles because it knows that it will still reach in the same number of turns. But now if we're breaking ties, it should be okay. If the ties are always broken by the distance to... It's a weird situation, I don't know. Alright, enough worrying about this. We'll worry about this tomorrow. Won't be much time left, another day and a bit, but we can probably churn this out tomorrow. Alright, cool. Yeah, maybe see you tomorrow. I guess, are you working on this quite heavily the next couple of days? I guess you're aiming to get into gold, hopefully, because you're within the top 200, so... So yeah, could be done. You're in the top 100 now. Alright. Did we... I've saved my thing, haven't I? Why can't I replay my... Oh. Pretty sure it's saved. Can I just do that then? Now the site is... Okay, there we go. All right. See you next time.